level of the model.
Yeah,
Then
I mean you can't use the very then that is a wrong approach. That is a wrong approach.
I mean that's a problem in these simulations. But unless you know it, that you went into that algorithm and found out the point where it starts rupturing is actually fed by the person. So then you are very unhappy. So one is not able to go into all the details always, and one accepts on face value what is being seen. But my personal experience has been on many occasions. I mean, why is simulation now a third? It is suggested as a third strategy. Theory, experiment, simulation. Well, probably we cannot really explain everything by analytical approach. But then there are so many discontinuities in between, especially if you talk of external material. You get reports to those kind of artificial intelligence. You don't know what is happening. Just feeding something, feed out something. So this is input, this should be done. Now you change the nature of the input, and you say again that nature of the output will follow the same pattern. Nobody knows. So that's why the situation is so complex that it is probably a simpler route. You know, the theory is not possible to complete. Why theory? I mean, you take Newton for example. He propounded a theory, which later on was found to have limitations. Then came Einstein, and now nobody knows who will come next and put forward another theory. So they have limitations. But you can always create a simulation of this entire universe, starting from the Brahmanda part. Do you know the computer?
Actually, sir, with simulations, what people are doing in other disciplines is they test the simulation algorithm itself. It's another kind of research. I mean, some XYZ group of people have developed a simulation. They have probably published or demonstrated and so on, maybe commercialized. Then another group of people, ABCs, they would take that simulation as such and then apply it with other constraints, other inputs, and see the result on the output and whether it satisfies the generally accepted standards or not. If yes, then they conclude that okay, this simulation is good enough to be used for this particular application. But if not, then they investigate into the algorithm as to which part of it actually caused this deviation, whether it deviated from some basic principles or not, and so on. And that way people are actually doing. It's not that when, for example, the quotation I gave about Professor Brosseau, he is an expert on simulation of electrodynamics. Basically, I came to know about his paper and I then wrote him a few emails. He was kind enough to reply me. I told him my particular PhD problem. He gave his thoughts about that. And gradually it became very clear that they were actually using a set of simulation tools all over the sort of globe in different universities and institutes, and they are verifying each other's data using different available simulation tools and different algorithms, whether they are giving same results or not. If not, then why? What are the differences in their simulations and where the loophole is, and that way they are also publishing. I mean, criticism itself is a contribution towards the science, and that way also they are doing it. And when I talked about this textile materials, fibrous assemblies, and the funny thing is his reply was very clear that he wrote a couple of papers in Journal of Applied Physics on nanotubes, carbon nanotubes,